PU2 aspirants, so welcome back to our channel, and as you know we are very near to the exam and it's high time to practice model test papers, right? So in this video I'm going to discuss the solutions of model paper 3 for chemistry. Okay, so these model papers have been released by the PU board. Okay, so you can download it from the website, or the link will also be, the PDF will also be provided in our WhatsApp channel, so you can join there. And yes, please attempt this paper with me so that you can understand which is your, like, what is your strength and weakness, which questions you are able to solve, which questions you aren't able, which chapter is weak. So everything you will understand if you solve the model test papers, right? So I'll be also telling you the marking scheme and how to write the answer, everything in detail. So please watch this complete video. Okay, let's get started here with the first paper pattern. You know already. We'll go to the first section of the questions, that is the concentration terms depend on temperature is. So we know molarity depends on temperature, right? So we know that molarity is equal to number of moles by volume, and volume is something which is affected by temperature. So that is why molarity is also affected by temperature. Next, identify the correct sequence of the number of unpaired electrons in the following ions. So we have here Fe3 plus is one of the ion, and if you remember, Fe3 plus has 5 unpaired electrons, which is the maximum unpaired electrons that is possible. So Fe3 plus should be at the highest, so we can eliminate this one. Okay, now if you see titanium 3 plus, okay, scandium, titanium is 4s2 3d2. Titanium 3 plus means 3 electrons will be lost, so we will have 2 electrons lost here, 1 electron will be lost here, so I will have 3d1. So it will have 1 unpaired electron, so this is the lowest possible. So I have titanium 3 plus here lowest, here highest, so option number C is the correct answer. We do not have to check for each and every option. Next, 4 haloalkane compounds represented by letter M, N, O and P having boiling points are given. Identify N here. So we have M, N, O and P. Okay, so M has a boiling point of 24 degrees Celsius, N has 38 degrees Celsius, O has 3.56 degrees Celsius and P has 101.6 degrees Celsius. Now what are the compounds given to you? C3H7, C2H5, CH3, CH3. Now if you see the number of carbons here is more, the iodine mass is also more. More is the mass, more is the boiling point. So definitely C3H7 is the highest one, that is this one. Okay, now if you see the next compound, the one which will be having the highest boiling point will be this one, because it has 2 carbon and bromine is also there. So after this one I can find this one is the next highest value, so here I can have C2H5Br. After comparing CH3Br and CH3Cl, so CH3Br is having more mass, so the next highest one, that is this one, will be CH3Br and this one will be CH3Cl, right? So now if you see here, N is which one? N is C2H5Br, because we have to identify N, so option number C here. Okay, next, glycine is an optically inactive alpha amino acid, right? So it is because of, so glycine structure, if you remember, it is like this: CHH, you have C double bond OH and you have NH2. Right, you can see that on this carbon 2 same groups are present, right? 2 same groups are present, so that is why it is an asymmetric, it is not a asymmetric carbon, not an asymmetric carbon, so that is why it is optically inactive, right? So presence of an asymmetric carbon, no. Absence of an asymmetric carbon, yes. Option number B here. Next, copper displaces hydrogen gas from dilute acid. No, we know that copper is having more reduction potential, so copper cannot produce hydrogen gas when it reacts with an acid. So statement 1 is incorrect. Copper 2 plus ions get reduced more easily than H plus ions. Yes, this is the statement is also correct. Copper 2 plus reduction potential is, see, Cu2 plus 2 Cu, reduction potential value you should remember 0.34. H plus 2 H2 reduction potential is 0. Okay, so that is why what I can say, that statement 1 is wrong but statement 2 is correct, right? Statement 1 is incorrect but statement 2 is correct, so option number D. Okay, Copper does not displace, so that is incorrect, and this one is correct, so statement 2 is correct. Next, the radioactive substance reduced to 1/4 of an initial concentration in 20 minutes. Then the time taken to reduce to 1/16 of the initial concentration. So it is radioactive decay, means it is a first order reaction, and we know that in first order reaction the half-life is independent of the initial concentration. So suppose I started from 1, then it will become 1/2, then it will become 1/4, then it will become 1/8, and this it will become 1/16. Half it is decreasing. Now from here to here it took 20 minutes. That means this is 10, this is 10, this one will be 10, this one will be 10. So total time taken will be 40 minutes, option number C here. Next, the products formed when phenol is treated with excess of bromine water. So you will get here excess of bromine water, you will get 2,4,6 tribromophenol, so only for option number B here. Okay, we won't get ortho and para-bromo separate product when you treat with excess of bromine water. Okay, next, which of the following observation is shown? Let's see question number 8. Which of the following observation is shown by 2-methyl propane 2-OL with Lucas reagent? So if I have 2-methyl propane 2-OL, okay, so it is a tertiary alcohol group. So tertiary alcohol means immediately turbidity will form. So turbidity will be observed immediately, option number C. Okay. Next, the transition metal present in red pigment of blood hemoglobin is. So that is your iron, option number C. This is from the application. The geometry of FeCO5. So you can 5, coordination number is 5. So coordination number 5, geometry is trigonal bipyramidal. So remember 4, 5 and 6. For 4 we have 2 geometry, square planar, okay, and tetrahedral. For 5 it is trigonal bipyramidal, and for 6 it is octahedral. So option number C here. Next, I can also draw and show you. So it is like this. Fe, you have CO, 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 CO and CO. Okay, so this is your trigonal bipyramidal. Next, we have match the following given in the list 1 to list 2. Gatterman-Koch reaction, COHCl, so A has to be 3, we can eliminate option number A. Then Stephan reduction is SN, so B has to be 1, eliminate option number D. Rosenmond reaction is H2, so C has to be 4, the eliminate option number C, it is option number B here. Next, an organic compound with the molecular formula C9H10O forms 2,4-DNP derivative, reduces Tollens reagent and undergoes Cannizzaro reaction. Reduces Tollens reagent tells us that it is an aldehyde. Okay, see how I can draw the conclusion. First, it is saying it forms 2,4-DNP. It reacts with 2,4-DNP. That tells me what? It can be an aldehyde or a ketone group. Okay. Next, it is telling that it is reduces Tollens reagent also. So if Tollens reagent is there, then I can tell that no, it is not ketone, it is only aldehyde. So this one is aldehyde. Next, it is saying it is having Cannizzaro reaction. Cannizzaro reaction, I can say no alpha hydrogen, means most probably when you see number of carbons is more than 6, okay, and it is having no alpha hydrogen, then most probably it will be a benzaldehyde, okay, derivative of benzaldehyde. On vigorous oxidation, it gives 1,2-dicarboxylic acid, okay, 1,2-dicarboxylic acid. So that means I can say the structure like this. See, you have CHO, this is must is there because we have something Cannizzaro reaction, so no alpha hydrogen should be there. So I got 6, 7, and if I make like this 8, 9. Okay, now if you see, if you do vigorous oxidation, aldehydes will get oxidized to acid. Even this one, what we can say, the hydrocarbon part will also get oxidized to carboxylic acid. So I can have 2-ethyl benzaldehyde, that is option number B here. Okay. Next, the following factor which does not affect the rate of the reaction is. Molecularity does not affect the rate of the reaction, option number A. Next, the correct order of basic strength of the ethyl substituted amines in aqueous solution is. This is very, very popular question. Ethyl amines we have 2 degree, 3 degree, 1 degree, okay, for ethyl amines, and for methyl amines it is 2 degree, 1 degree and 3 degree, okay, for methyls. So we have here 2 degree, so here it is 3, 3, we can eliminate, 2 degree, 3 degree, 1 degree and then ammonia, option number A. Next, N-ethyl benzene sulfonamide soluble in alkali because of what? Because of the presence of acidic hydrogen. It does not contain any acidic hydrogen, no. It contains hydrogen atom attached to the nitrogen and is strongly acidic, yes, okay. It is acidic, so it is not acidic, this is wrong statement. It does not contain, it contains, so this is also wrong statement. Now we'll do some fill in the blanks question. During surgery was used as anesthesia. So we know that chloroform is used as anesthesia. So I can write here CHCl3. The rate of a particular moment of a reaction is expressed as, at particular moment rate is instantaneous. Okay. The dimagnetic lanthanoid ion is, so we have only one here, we can easily guess it, it is Yb2+. Next, Williamson ether synthesis of preparing dimethyl ether involves dash reaction for the attack of the methoxide ion on methyl chloride. So it is your SN2 mechanism, so I have SN2 here. Nucleotides are joined together by phosphodiester linkage, okay. Phosphodiester atoms of pentose sugar linkage between 5' and 3', okay. Now we will go to section B, 2 marker questions. So which chapters will give you 2 marker questions? You will be getting 2 marker questions from haloalkanes, alcohols, biomolecules, solutions and D and F block. So in blueprint this 2 marker question can either be from solution or from chemical kinetics, okay, but in this paper they have taken solutions, okay. Similarly here also it can be D and F block or coordination, but they have taken from D and F block. Okay, so let us see the first question here. So name one important alloy which contains maximum percentage of lanthanoid metal. Mention one of its use. Very simple mark distribution is there. This can be a very easy question. Just you have to name, that will give you 1 mark. One use will give you 1 mark. So it is mic metal, right? So if you write this much in the answer, this one will give you 1 mark. And mic metal is used in what? It is used in producing bullets, shells, lighter. So this will give you 1 mark. Okay, very simple and easy question. 2 marker section I feel generally is very easy to score. Next we have haloalkanes and haloarenes chapter, name reaction, easy. What is a Fittig reaction? So Fittig reaction you have to first write the explanation and then the example, you will get 2 marks. So you can see here, aryl halides when treated with sodium in dry ether give compounds where 2 aryl groups are joined together. It is called Fittig reaction. You can take here any chlorobenzene, bromobenzene, anything in presence of sodium and dry ether, that will give you diphenyl. Okay. Let us see the next question here. Write the expression to relate the cryoscopic constant and the change in the enthalpy of fusion. So we have here, sorry, 1 second. Yes, cryoscopic constant is Kf. Okay. So here we have R dot M Tf square divided by 1000 into delta H of fusion. Okay, so this is the formula. Explain the terms involved in it. So we have to explain the terms. So what is R here? R is gas constant. Okay, then I have M here. M is the molar mass of the solvent. Okay, then we have Tf. Tf is the freezing point of pure solvent. Okay, then we have delta H fusion. It is the delta H fusion, or I can say enthalpy of fusion. Enthalpy of fusion of pure solvent. Okay, so these are the terms and the formulas that you can write. Next we have 24, give an example of female sex hormone and write its function. So example will carry 1 mark and function will carry 1 mark. So you can write any one of this. If you write estradiol, its function is to development of secondary female characteristics and participate in the control of menstrual cycle, and progesterone responsible for preparing the uterus for implantation of fertilized eggs. Okay, so you can write any one here. Okay, so this will carry 1 mark and this function will carry 1 mark. I have given you 2, you can write down any one. Easy question, direct question. Next, coming to, we have, so we got questions from which chapters? Let us just see once. First we got from DNF block, then we got from haloalkanes and haloarenes, then we got from solutions, we got from biomolecules, and next one is from alcohols, phenols and ethers. So complete the following reaction and name the reaction. This is very simple. This is your Reimer-Tiemann reaction and you will get salicylic aldehyde, or you can say 2-hydroxybenzaldehyde. Okay, so this is Reimer-Tiemann reaction. So this will carry 1 mark and this will, so writing the name will carry 1 mark, writing the product will carry 1 mark. Okay, now we will go to 3-marker question. So a 3-marker question is of 2 types. One will be for your inorganic chemistry, one will be for your physical chemistry. In inorganic chemistry, you will get 5 questions from DNF block and coordination. It is like 2 plus 3 or 3 plus 2. Okay, but in this paper 2 DNF block and 1 coordination question is given. After that you will have 4 questions from physical chemistry. 1 will be from solutions, 2 will be from electrochemistry and 1 will be from chemical kinetics. So let us see this. You have a first question from coordination. Using abbreviations of the following ligands, identify the number of donor sites and write the formula of each ligand. Okay, so if you have EN, that is ethylene 1,2-diamine. So this is the formula. Okay, you have NH2 CH2 CH2 NH2, and here you can cite, we have two donor sites, this nitrogen and this nitrogen. Okay, so the donor site, or I can say the number of donor site is 2 here. Okay, next coming to EDTA, so you have NCH2 CH2N, CH2COO minus, CH2COO minus, similarly here also it is there. So now we have how many donor sites? 1, 2, 3, 4, 5 and 6. Okay, next we have PPH3. So PPH3 structure is like this, it has only 1 donor site. Okay, next we'll go to question number 27, that is the second question from DNF block, it is there. So write the equations for the preparation of KMnO4 from pyrolusite ore. What is the color of KMnO4 crystals? This is very simple and direct question. Okay, easy. This question is a very expected question as well. So there are 2 methods in the preparation. So first one is what? You don't have to write this statement. Okay, this is not required. You can directly write down first MnO2 is converted to K2MnO4, that reaction. So MnO2 in alkaline medium gets converted to K2MnO4, then K2MnO4 from in acidic medium gets converted to MnO2 minus. Okay, so just you can write down these 2 reactions, that will give you 1 mark here and 1 mark here, and the color will give you 1 mark here, that is KMnO4 crystals are dark purple color. Okay, okay, next 1 second. Yeah, okay. Next question number 28, using valence bond theory, explain the geometry of COF6. Okay, this is small mistake, COF6 3 minus, atomic number of cobalt is given. So I will tell you how to write this, then I will also show you how to write. So here first step you have to write is the oxidation state of cobalt. So if you see cobalt is in +3 oxidation state, so I will write cobalt +3 electronic configuration is 3d6, right? Cobalt is 3d7, 4s2, 3 electrons are lost, so it will be 3d6. Now you have to draw and show this 3d6 electrons. Okay, so I have 1, 2, 3, 4, 5 and 6. Okay, now what the next thing you have to write is about the ligand. So what happens? F minus, okay, F minus is a weak field ligand. Okay, weak field ligand, so pairing of electrons does not take place. You have to write. If it is a strong field ligand, you have to write it take place or does not take place. So now what we can write? Again, I'll write the electronic configuration for CO3 plus. We have 3d6, 4s and 4p. I will show. We have here 3d. Okay, 1, 2, 3, 4, 5 and 6. Now here I have 4s, 4p and 4d. Okay, so what happens? This is 4s, this is 4p and this is 4d. Okay, now what I can say here is, see, this we need how many empty orbitals? We require 6 empty orbitals. Okay, so 1, 2, 3, 4, 5 and 6 empty orbitals are already present. Now what will happen? These 6 empty orbitals, this will there is no involvement of these d electrons because there is no pairing here. These 6 orbitals will undergo hybridization. So you have to show it like this. Okay, so you can show here sp. What is this hybridization now? sp3d2 hybridization. Okay, now you have to, so this is your second part. Okay, this much you have to write in the second point. Third thing, what you have to write? You have to draw 1, 2, 3, 4, 1, 2, 3, 4, 5 and 6. You can write down here sp3d2 hybrid orbitals. Okay, and here we have CO F6, right? So F will donate electrons. Okay, and here each F will donate 2 electrons. Clear? So I can show like this. Clear? So that is your hybrid orbital and the donation of electrons. Now what we can write? Next thing, the question is asking about geometry, hybridization and magnetic property. So I have geometry here. Okay, so geometry will be what? Geometry is octahedral. Why? Because it is coordination number is 6. Then we have hybridization. Okay, hybridization is sp3d2. Okay, hybridization is sp3d2. Next, what is given? Magnetic property. Okay, now magnetic property, you can see there are 4 unpaired electrons, right? So that is why it will be paramagnetic. Okay, so you have to write these 3 points. These 3 points actually carry marks, but without writing or explaining this one, you cannot write this one. Okay, so make sure that you explain this part and then you write this one. So we can see the answer this way. You can mention sp3d2, octahedral and paramagnetic. Next, we'll go to give any 3 applications of coordination compounds. This is also very easy, direct question. So one thing you can write, chlorophyll. Okay, chlorophyll contains what? Magnesium, and it is responsible for photosynthesis. Coordination compounds are used as catalyst for various industrial processes. Then gold and silver complex ions are used in electroplating. There are so many other applications as well. You can mention them. Cisplatin is used for the purification or for the cure of cancers. So many other applications are there. You can write any 3. Okay. Next, we'll go to next 2 marker question, that is transition elements have higher enthalpy of atomization. Give 2 reasons. Among 3D, 4D series of transition elements, which series has higher enthalpy of atomization? So first you have to write why they have higher enthalpy of atomization. Okay. Next you have to write out of 3D and 4D which is having higher enthalpy of atomization. So you can see here answer. The first reason for high enthalpy of atomization is strong metallic bonding. Okay, so why this strong metallic bonding is there? This is due to the large number of unpaired electrons. So simply you have to write the transition elements have a large number of unpaired electrons in their d orbitals which participate in the metallic bonding. This results in stronger metallic bonds require more energy to break the bonds during atomization. Next point is higher number of interatomic interactions. So due to the availability of d electrons, transitions metals have stronger interatomic interactions. So there is not only metallic bonding, but there are other interatomic interactions as well. Okay, so main thing is metallic bonding, that is due to unpaired electrons, and due to this d electrons there are other interatomic interactions as well. Now out of, so this will carry 1 mark, this will carry 1 mark. Now for out of 3D and 4D, which one is having higher enthalpy of atomization? 4D series. Okay, so that will give you 1 mark. With this we are done with the 3 marker questions from the inorganic chemistry. Now we will have 3 marker questions from chemical kinetics. So what does P and ZAB represent in the equation PZAB e to the power of EA by RT? Okay, name a factor on which Z depends. Okay, so we have the answer here. P stands for your orientation factor and Z is your collision frequency. Okay, and Z depends on the, you can say, the energy of collision and the orientation of the collision, right? So yes, P is what? Probability factor or orientation factor or steric factor, anything you can write here. ZAB is nothing but collision frequency. Now collision frequency depends on sufficient kinetic energy and proper orientation. Okay, so you have 1 mark for this one, for writing P, 1 mark for writing ZAB, and any one you can write here, that will give you 1, or you should write both and half of you will get 1 mark. Okay. Next, question number 32, name the fuel cell used in Apollo space program and write its anodic and cathodic equation. This is also direct question, but yes, anodic and cathodic reaction of fuel cell is little bit difficult, but yes, very direct question. So which fuel cell is used? Hydrogen oxygen fuel cell was used in the Apollo space program. Hydrogen will be at the anode side, oxygen will be at the cathode side. Okay, so hydrogen is there at the anode side and oxygen is there at the cathode side. So cathode there is reduction, so oxygen gains electrons, and anode there is oxidation, so hydrogen loses electrons. Okay. Next we have question number 33, give any 3 differences between ideal and non-ideal solutions. So here are the 3 differences. So ideal solution obeys Raoult's law, non-ideal solution does not obey Raoult's law. In ideal solution, the AA-BB interactions and AB interactions are same. In non-ideal solution, AA-BB and AB interactions are different. Okay. Now here delta H mix is equal to 0 and here delta H mix is not equal to 0. V mix is equal to 0, V mix is not equal to 0. They do not form any azeotrope, they form azeotrope. So you can write any 3 difference point is fine. Any 3 will work for here. Okay. This is also direct question and easy question. Next, 1 second. Let us see the next question here. Mention any 3 thermodynamic quantity determine the electrochemical cells. Okay. So here are the 3 quantities that can be determined. You can write Gibbs free energy, equilibrium constant, enthalpy and entropy. Okay. So any 3 from here you can write down. Next, we'll move to section D, that is your 5 marker question. So here you will be getting haloalkanes 1 question, alcohols 1 question, aldehydes 2 questions, amines 1 question, biomolecules 1 question. So there will be 6 questions and you have to attempt any 4 here. Okay. So let us see the first question. Okay, sorry, this question is repeated. Okay. Next, coming to this question, answer any 4. Okay. So this I have already discussed. The first question is write the reactions involved in the conversion of toluene to meta-nitrobenzoic acid. So the first question is from aldehydes, ketones and carboxylic acid. The pKa values of acids are given and you have to arrange them, okay, in the increasing order or decreasing order of acidity. So first of all, write the reactions for the conversion of toluene to meta-nitrobenzoic acid. This is very simple. Toluene can be converted to benzoic acid, then benzoic acid is meta-directing group, electron withdrawing group. So you can introduce nitrogen, NO2 will go to the meta position. Next here, pKa values are given, so you know lower the pKa value, higher is the acidity. So here you can see the last one, trifluoroacetic acid. Trifluoroacetic acid has the least pKa value, that means it is the highest acidic one. So I will have trifluoroacetic acid. I am just writing in short. Okay, then I have which acetic order? Then we have 4.19, that is your benzoic acid. So after trifluoroacetic acid, pKa value least is for benzoic acid. Okay, and after that we have acetic acid. So we have to explain why is this order correct. Okay, so let us see the first one. So here you can see CH3 is converted to COOH by using KMnO4 and KOH. Then by treating concentrated HNO3 and H2SO4, you can introduce nitro group at the meta position. Order is trifluoroacetic acid, benzoic acid, and then acetic acid. What is the reason? Due to the presence of electron withdrawing group, right? Electron withdrawing group increases the acidity. Okay, next we'll go to haloalkanes and haloarenes. Write the mechanism involved in the conversion of 2-bromo-2-methylpropane to 2-methylpropane 2-OL. Okay, so this is your SN1 reaction. 2 steps mechanism is there. Next, what are the enantiomers, and name one physical properties which differs in enantiomers. So in this, the first step is the formation of carbocation, the second step is the attack of nucleophile. But before writing the steps, you have to write the reaction. That carries 1 mark. 2 steps will carry 2 marks. So total 3 marks. Here, what is enantiomer's definition? 1 marks, and the physical property will give you 1 mark. So let us first write down here 36A. The first thing that you have to write is 2-bromo-2-methylpropane. So I have like this 2-bromo-2-methylpropane. Okay, and if that one is treated with OH minus, you will get CH3 . Okay, so this is not a step, but you are telling what actually is the reaction, and here it is better if you mention the name also. 2-methyl 2-bromo propane. Okay, next we have 2-methyl propane 2-OL. Okay, so this is the first thing that you need to write for the mechanism. Then you can write down it follows SN1 mechanism. Then you write the mechanism here. Okay, so here you can write down the mechanism. First step is a slow and reversible step. You do not have to write this many big sentences. You can just write down the first step as formation of carbocation. Okay, formation of carbocation. Then you will lose bromine here, carbocation is formed. The second step is the fast step. You can write down attack of nucleophile. Okay, so this nucleophile OH minus will attack here, so we will get a tertiary alcohol, that is the product. So 2 mechanism, 3 steps you will write, 3 marks. 2 marks is a step, and first one is the reaction. Next, what are enantiomers? Enantiomers are non-superimposable mirror images, and the only thing that they differ is the rotation of plane polarized light. Okay, so this one will give you 2 marks here, so total 5 marks. Next, give the mechanism in. So now we are going to alcohols, phenols and ethers chapter. Give the mechanism involved in the acid catalyzed hydration of ethene to ethanol. So this itself is a 3-step reaction, so this will give you 3 marks. Name the enzyme involved in the fermentation of glucose into ethanol and write the chemical equation. Naming of enzyme 1 mark, reaction 1 mark, so this one will be 2 marks. So let me first tell you the answer for this one. So what happens? Glucose, once it is formed, it's the name of the enzyme will be zymase here. Okay, so what is the name of the enzyme? Zymase. So zymase converts glucose to ethanol. The reaction is given here. C6H12O6 will give you 2 molecules of ethanol and 1 molecule of carbon dioxide. This second one is your answer. Okay, this second reaction is the answer. So this will carry 1 mark and this one will carry 1 mark. So total you will get 2 mark in the B part. Now A part is very direct. Reaction mechanism, 3 steps are there. So first step is what? The protonation of alkene, okay, sorry, protonation of ethene to form carbocation. So that is the first step. Second step is the attack of the nucleophile. The third step is the deprotonation of the alcohol. So you can see here first water is attached, okay, sorry, first H is attached and then carbocation is formed. In the second step water attacks here, and in the third step there is a deprotonation and we get ethanol back. Okay. Next, question number 38. What does tertiary structure of protein represents? Give its two molecular shapes. Okay, so what does it represents? 1 mark. Two major molecular shapes, 2 marks, so total 3 mark. Write the Harvard structure of alpha D glucopyranose, so that one will be carrying 2 marks. Okay, so let us see carbohydrates, easy and direct question. So what does tertiary structure represents? Overall folding and superposition of the polypeptide chains. Two major shapes are fibrous and globular protein, so this will carry 2 marks. Next, this diagram, if you do correctly with all the leveling, alpha glucopyranose OH has to be below, so this will give you another 2 marks, so total 5 marks you will be getting. Okay. Next, question number 39. Identify the products A, B and C. So this is from your amines chapter. Name any one biologically active amino acid used in the following. Okay, so this is somehow mixed. Okay, not mixed. Okay, so first of all, if I react, if you find A, B and C, you will get 3 marks here. Okay, and if you write these two, you will get 2 marks here. So first of all, when you do OH partial hydrolysis, you get amide here. So what will be A here? A will be this one. Okay, next with NaOH and Br2, this one will be removed, so you will get 1, 2, 3 NH2. Okay, then with NaNO2 and H2O, you will get OH. Okay, so these are the products formed here. So we know this is A, I have already explained, this is B and this is C. A, B and C you can write down separately. Now this part, if you have read the introduction part of the amines chapter, I have also given you in Decode NCERT. This is important. To increase the blood pressure, we have adrenaline and ephedrine, and that is used to maintain anesthetic, that is your Novacin. Okay, Novacin is used as an anesthetic. Adrenaline and ephedrine is used to increase the blood pressure. Clear? Now we will move to next question number 40. So this question is also from aldehydes, ketones and carboxylic acid. We have an organic compound C8H8O which forms an orange red precipitate with 2,4-DNP reagent and gives yellow precipitate on heating with iodine. So first of all, these two reactions tells that it is either an aldehyde or a ketone. Okay, and it has this CH3CO group because it is showing you haloform reaction. It neither reduces Tollens reagent nor does it decolorizes bromine water. Neither it doesn't reduces Tollens reagent, that tells us that it has to be a ketone group. Okay, okay. Next, on oxidation with chromic acid, X gives a carboxylic acid Y having molecular formula of C7H6O2. Okay, identify the compound X and Y and write all the reactions involved. So whenever I have C8H8O more than 6 carbon, you must think about what I'll say, benzene ring. Okay, so C8H8O with a ketone, I can draw like this: 6 carbons here, 7 carbon here and 8th carbon here, right? Now if I see this one, what is the question here? Identify the compound X and Y. So Y acid, if it undergoes oxidation, you will get the acid COOH, right? This will be the then, and write all the reactions involved. Okay, so let us see here. The first one here is the reaction with 2,4-DNP. So you can write down this one. See, so our guess is correct. X is your acetophenone. When you react with this one, 2,4-DNP, this H2O is released and we get a imine here, right? This is the first reaction. Then it is showing that it is reacting with iodoform reaction as well, right? So you have this one, 1 second, let me go back. What is the next one? It gives a yellow precipitate on heating with iodine in the presence of sodium hydroxide. So you have here iodine, okay, iodine plus sodium hydroxide, so it will give you C6H5COO minus Na plus and CHI3. This is 1 mark, this is 2 mark. Okay, next, it is undergoing oxidation. X is undergoing oxidation, so you have, if the simple oxidation takes place, this one will give you, so this is your third mark third reaction. So you have got 3 marks here. Writing X product correctly, that is your 4th mark, and writing Y correctly, that is your 5th mark. Okay, so that is why you will get all the 5 marks correct here. Now we'll go to numerical section. So numerical carries 3 marks. You will get 2 questions from solutions, 2 from kinetics, and 2 from electrochemistry. So total there will be 6 questions, and you just have to attempt 3 out of 6. Okay. So the first question is from the solutions chapter. Calculate the molality of 20% W by V aqueous solution of Ki given the density of aqueous solution is 1.2 gram per centimeter cube. Molar mass is given. You have to calculate the molality, right? Now let me explain what is the meaning of this 20% W by V. That means what? 20 gram of Ki, okay, in 100 ml of solution, right? Now what is the density of this solution? Density, so we know that density is equal to mass by volume. So density is given, volume we know 100 ml, so I can calculate the mass of solution. Okay, so that is how much? 1.2 into 100. Okay, that is 120 grams. Now in this 120 gram, 20 gram is Ki, that is the mass of the solute. So what is the mass of the solvent? Okay, what is mass of the solvent? 120 gram minus mass of the solute is 20 gram, that is 100 grams. Okay, now if I want to calculate the molality, right? So what is molality here? Number of moles of Ki. Number of moles is what? Given mass by molar mass, okay, into 1000 by mass of the solvent is 100 grams. Okay, so that means 200 divided by 166, that will give you molality, which will account to 1.506. Okay, you can solve it and you can find the answer. Next, so this was, I can say, little difficult question because you have to identify this term. 20% W by V means 20 gram of Ki in 100 ml of the solution. Okay, that is what you have to identify. Next, vapor pressure of the water at 293 Kelvin is 17.535 mm of Hg. Okay, so we have vapor pressure of water as 17.535 mm of Hg. Okay, and then calculate the vapor pressure of water at 293 Kelvin when 25 gram of glucose is dissolved in. So what is the mass of glucose dissolved? 25 gram. What is this is mass of solute? Then mass of solvent. Mass of solvent is 450 gram of water. And yes, so this is very simple question. This is from your relative lowering of vapor pressure. So you have P naught minus P by P naught is equal to XB, right? So if I want to calculate the number of moles of solute, which is your glucose, right? Number of moles of glucose is given mass by molar mass. Similarly, number of moles of water is given mass by molar mass. Okay, this I can find out. So what is now XB? XB is equal to N of glucose by N of glucose plus N of water. So that is equal to, okay, in such type of questions we can ignore the number of moles of glucose. So I can simply write 25 by 180, okay, divided by 450 by 18. Okay, so this is your mole fraction of glucose. Now I can substitute here. Okay, so what is the value of P naught? P naught value is 17.535 minus P by 17.535 is equal to XB is equal to 25 by 180 into 18 by 450. Now if I solve this and find the value of P, you will get 17.4386 mm of Hg. You can check the calculation. So this one will carry 1 mark, okay, this substitution will carry 1 mark, and final answer will carry 1 mark. Okay, Next, we will go calculate the EMF of the following cell and state whether the cell is feasible or not. So, to calculate whether the cell is feasible or not, you need to see the E value, E naught value should be positive. Okay. So, we can find out this one. So, here Br minus is undergoing. So, what is the oxidation reaction? So, you have Br minus gives Br2 by losing 2 electron, and then reduction we have 2H plus 2 electron will give you H2. Okay. Now, if I add this one, what I will get? 2 Br minus plus 2H plus gets Br2 plus H2. Okay. So, now what is Br minus concentration? 10 to the power of minus 2. H plus concentration 3 into 10 to the power of minus 2. Okay. Then you have Br2 is liquid, that is not important. H2 pressure is 1 bar. Okay. So, now E naught value is given to me. So, here what is there? See, E naught, what is the E naught value? E naught value will be E naught of cathode minus E naught of anode, right? So, what is here cathode value? Cathode, if you see, H plus is cathode, so 0 minus anode is 1.09 volt. Okay. So, I will get minus 1.09 volt here, E naught value. So, let us now write down the Nernst equation, E equal to E naught minus 0.059 by N log of, I have log here, nothing to be substituted in the numerator, then I have Br minus square and I have H plus Br minus square and H plus square as well. Okay. So, E naught minus 1.09 minus 0.059 by 2. So, for easy calculation, let me take it as 0.06. Okay. Log of 1 by, what is Br minus concentration? 10 to the power of minus 2 square. Okay. And H plus concentration is 3 into 10 to the power of minus 2 square. Okay. So, you should not forget to take this square terms here. Now, if I solve this, okay, if I solve this, I will get E value as minus 1.298. Okay. So, I will get E naught value, sorry, E value as minus 1.298 volt. Okay. Now, this one will take what? The, if this value is coming negative, then I can say that the cell is not feasible. Cell is not feasible. Okay, fine. Next, moving to question number 4, calculate the limiting molar conductivity of Cl minus by using the data CaCl2 is having this data. Okay, so lambda naught of CaCl2 will be equal to lambda naught of Ca2 plus 2 times the lambda naught of Cl minus. Now, lambda CaCl2 is 271.6 and lambda Ca2 plus is 119 plus 2 times lambda naught of Cl minus. Okay. Now, here we have this one 6 minus 0 6, 11 minus 2 9 2, 6 minus 1 5 and 252.6, right. So, I think, sorry, 152.6. Let me just check. 9, 10, 11, 5, 6, 7, 1. Yeah, this I am getting is equal to 2 times of Cl minus. So, if I just want to calculate for 2, so I have to do 152.6 divided by 2 is equal to Cl minus. So, I will get 76.3. Okay. So, you can write answer will be 76.3 unit of S centimeter square mole inverse. Okay. Whatever is given here. Right, this is also very simple and easy question. So, we have got one question from solution, one question from and 2 questions from electrochemistry. Okay, I think that is the distribution, right? 1 second, let me see. Okay, first 2 questions I got from solutions, next 2 questions are from your electrochemistry, next questions will be from kinetics. The rate constant of a reaction is 60-second inverse. How much time will it take for the reaction to reduce the initial concentration to the reactant of its 1/16th value? Okay, rate constant is already given. So from the rate constant I can say that it is a first order reaction. So I have K is equal to 60 second inverse, right? Then I have A value, I can write A naught as 1, okay? And what is A value? 1 by 16th of the initial value, so let it be like this. Then I have to find T, okay? So I can write the equation KT is equal to 2.303 log of A naught by A, okay? So what will be the value of T here? 2.303 by K is 60 log of 1 by 16. So it is 2.303 by 60 log of 16, that is equal to 2.303 by 60 log of 2 power of 4, okay? That means equal to 2.303 by 60 into 4 into log 2 is 0.301, okay? Now if I solve this, I will be getting 4.61 into 10 to the power of minus 2 seconds, okay? Next, last question. In the given reaction A to B, the rate constant K is given to you as K is 2.0 into 10 to the power, okay, 2.0 into 10. I think here some power will be there, liter mole inverse second inverse. Find the initial rate of the reaction when A is 0.5, okay? So if you see the units here, right, what is the unit? Liter mole inverse second inverse, okay? Liter mole inverse second inverse. So this tells you that the unit, it is a second order reaction. So I can write R is equal to K into A square, okay? So K value is 2 into 10, okay, into A square means 0.5 square. So I can write it as like 2 into 10 into 1 by 2 into 1 by 2, right? So I can cancel this one, so I will get 0.5 into 10, okay? So answer here will be, so I think this one must be minus 2, okay? So that is why 0.5 into 10 to the power of minus 2. You will get the answer here, okay? Now since we are finding rate unit is always same, that is mole liter inverse second inverse, okay? So here I have to change mole liter inverse second inverse. So you can see here K unit is what? K unit is liter, K unit, right? Yes, liter mole inverse second inverse. Then A unit is what? Mole liter inverse, and we have mole liter inverse, 2 times it is there, right? So 1 mole 1 liter will cancel, we will be left with mole liter inverse second inverse, okay? This is also very simple and easy question. So yes students, these were the solutions of your model paper 3, and the questions were very simple and easy. Easily you can score good marks in this type of paper. So let me know what was your thinking about the level of the paper, and if you have any doubt in any particular question, you can put down that in the comment section. I will definitely address to it. So thank you for watching and see you soon in the next class.